Welcome to Calculus. Today we will investigate finding derivatives from graphs, focusing on sums and differences without equations. So again, what we're looking at is how do I find a derivative of a function just given its graph and not working from any equation whatsoever. So we'll take a look at, again, a set of graphs that we're going to consider are our f of x and g of x. So the upper piecewise function here, we're going to consider that as f of x. The lower piecewise function is g of x. And we've got two other functions that are defined as a sum, and then the other one as a difference of my two f and g. So the first one we see here is u of x, and that is the sum of f of x and g of x. And then we also have v of x, which is the difference. So v of x is f of x minus g of x. So let's take a look at three different derivatives that make use of this sum and difference configuration. So our first task here in part A is to find the derivative of u at the x value of -2. So what I'll do is I'll bring that function that we're calling u of x, and let's just again remind ourselves u of x equals f of x as a function, so the value y of that function plus the y value of g of x, and that sum defines u of x. So if I apply my derivative rules, the derivative of u of x, the sum rule would say that that's equal to the derivative of f of x plus the derivative of g of x. Once we see that pattern, we just need to take a look at what kind of functions f and g are. So we already noticed that they're piecewise, and all the pieces, both of the upper f of x and the lower g of x, are linear. So when I'm asking what's the derivative of a linear function, recall we're saying what's the slope of the tangent line at that x value. Well, on a linear function, the slope of the tangent line is the same thing as the slope of the function itself. So really when I say, like I'm going to put in u prime at -2, that's really saying, okay, that's the slope of f function at -2 plus the slope of g function at -2. And so really what I need to find out from my graph are what are the slopes of my various parts on these piecewise functions. So I'm going to do that right now just to fill in here. So this left-hand piece, if I look at its slope, this upper left-hand piece of f of x, it's down one to the right one, down one, right one. And that's a constant slope. So I'm going to go ahead and write this m equals -1, and that's for that left-hand piece. I'm going to go ahead and just outline that in green. Let's go ahead and define the slope of all these parts for both functions f and g. So this middle piece of the f function is totally flat. So that definitely has a slope of 0. And then the right-hand part of f of x, again, it's linear. That slopes up 1, right 2. Kind of looks like that, but not exactly. So you got to be careful the way you count. I'm going to go from point to point. So up 1, 2 over 1, 2, 3, 4, 5. So that's a slope of 2/5. Let's also catch the slopes of the g function. So g has just two pieces, this lower left-hand lower part. So again, I'll count from point to point. So up 1, 2, 3, 4 over 1, 2, 3, 4, 5. This has a slope of 4/5, positive 4/5. And then that last piece there on the far right, it's got a negative slope. It's pointing down towards the right. So we'll count from point to point again. That's down 1, 2, 3 to the right. 1, 2, 3, 4. So that slope is -3/4. So we'll use those slopes because really what that's telling me is what's the derivative of that function within that particular interval of x where that piece is is the definition of the function. So I need to find the x values of -2, -2. So on f function, where -2 is right here. So that's that slope of -1. So I'm going to just go ahead and plug that in. The derivative of f at -2 is -1. The g function at -2 is this left-hand part. So again, I just found -2 traced down to the graph. So the slope there is 4/5. So what we're trying to calculate is what's -1 plus 4/5. And that adds very easily. That's going to be -1/5, which would have the decimal value -0.2. And we'll box that. Let's take a look then at the derivative of the v. So v, if you return back to the definitions here at the top, v of x is the difference between f of x and g of x. So I'm going to write that setup. V of x equals f of x minus g of x. And again, if I apply my, in this case, the difference rule for differentiation, that means the derivative of v of x is going to be equal to the derivative of f of x minus the derivative of g of x. But again, notice if I plug in that x value of 2, really what I'm looking at is what are those individual slopes. So really we're looking for what's the slope of the f function at 2. Then we're going to subtract from it the slope of the g function also at 2. So those are the two things we need to find. So we'll find the x value of 2 and trace up to the f function. So that's that right-hand part. Slope there is 2/5. And we're going to subtract from 2/5 the value of the slope of g of x at 2. So again, below that line, if I trace up to g function, that slope we found was -3/4. So this is going to be minus -3/4. So we do want to combine those two fractions. It is going to turn, that double negative will turn positive. So I see my least common denominator there is going to be 20. If my two different denominators are 5 and 4, they share no factor, so I just multiply them together. So the 5 I would be multiplying by 4. So that's going to be 8/20. And then plus, I'll need to multiply the 3/4 by 5 above and below. So that's plus 15 over 4 times 5 is 20. So when I add that up, that's going to be a grand total of 23/20, which will have a value of 1.15. And we'll box both of those. Again, we'll give both the fraction and the decimal value. So that's if I'm just taking derivative of the sum function or the difference function. We just look at the slopes. Let's take a look at one last example here that involves a constant multiplier out front. So here we've got 3 times the derivative of u at 5. So if, again, I pick up the u function, that's defined as the sum function. So I just want to write it here. U of x equals f of x plus g of x. And we just need to think what happens when I place a constant multiplier out front. So if I'm looking for 3 u of x, that's really 3 times parentheses, or really brackets, of f of x plus g of x. So the constant multiplier, again, just sits out front, but it does need to be distributed to both, or add f of x and g of x up and then multiply by 3. Same holds true for the derivative. So if I have the derivative of u of x, which is going to be the derivative of f of x plus derivative of g of x, again, if I place a constant multiple out front, it'll treat the right-hand side, the sum part, the same. I just put the 3 and then brackets around that whole sum. Well, this is at 5. So again, we'll set it up. So I'm calculating 3 times the derivative of u at positive 5. So we're really looking at the slope of the lines where x is 5. The good news is we just used those. So we've got that recorded. We do need to actually do the sum instead of the difference, but let's catch up there. So here in the middle, the derivative of f at 5 plus the derivative of g at 5. So that tells me again, what's my setup going to be? Let's make our substitutions. So here I've got the 3. And then I need to figure out what's the derivative of f at 5. So if I find 5 on my graph and trace up, well, that's that same slope of 2/5 that we just used in part B. I am adding instead of subtracting, and then we'll find that the same part of g of x is highlighted here at 5 as well. So if I go to 5 and then trace down, well, that's still on that part of the graph where slope is -3/4. So then what I want to do is just add those up. So I've already decided, okay, least common denominator there is going to be 20. So this is going to equal 3 times, we'll go ahead and write those as fractions with a common denominator. So again, I multiply by 4. So that's going to be 8/20. Plus negative is going to be minus. So I need to note that difference. And then this term -3/4, I will multiply by 5 above and below to get that common denominator 20. So that's 15/20. And now I need to subtract. So 8 minus 15 is going to give me a numerator of -7/20. And then multiplying that through the 3 will multiply times the numerator -7. That's -21/20, which is -1.05. And that we can box. So thank you for joining for this investigation of finding derivatives of the sums of functions from a graph where we don't have any equation involved whatsoever, but we're interpreting the derivative to be the slope of the line itself, since the tangent lines would have the same slope as the original parts of the linear piecewise function. So I'm going to let you go work on your own derivatives of sums and differences from a graph. Thanks for joining. See you soon.